Today we're going to look at factorization, and in particular we're going to look at 4 different methods for factorizing expressions. If you remember, factorization, when we say factorization, we mean just the opposite of expansion. So while with expanding we were going from something that looked like this to something that looked like this. Okay, that's expanding. With factorization, we're going back the other way. So we're going from something that's a series of terms into something that's written as something in brackets with something else multiplied by it. So it's just the reverse process. Now, the problem with factorizing is it's often not as easy to factorize something as it is to expand it. The first method we're going to look at for this is called the highest common factor, and you should always check if this can be done. Always try this one before any other factorization methods that we're going to do later. The reason, let's try first, I should write here. The reason we want to do that is if we do the highest common factor, it makes the other methods easier. And the highest common factor, as the name suggests, means that we're looking for the biggest or highest, okay, the most that we can, that is a common factor of all the terms. So common meaning each of them has it, okay, and factor meaning something that we can divide by. So having a look at this first example we've got here, 7a squared b minus 14a cubed b. I'm looking for the highest common factor that I've got there. And the best way to find this is to look at the coefficients to start. I've got a 7 as the coefficient of the first term and a negative 14 as the coefficient of the second one. And I'm thinking about what's the highest number that both of those can be divided by. What's the highest number that I can divide 7 and 14 by exactly? It's not hard to see that that is going to be 7 is the highest common factor. Negative 14 can be divided by 7 exactly. 7 can be divided by 7 exactly. So as far as the coefficients go, that's the highest common factor, but we also need to look at the algebra. And what we're looking for is common terms. So we can see here the first term has an a squared, the second one has an a cubed, so that means there's a common factor of a squared. Okay, the a squared can be divided by a squared, and this a cubed can also be divided by a squared, so we can bring that out the front. Next we look at the b's, and we can see that both terms have a common b in them, so we can bring that b out the front. This term can be divided by b, this term can be divided by b. And once we've identified that highest common factor, in this case 7a squared b, we can now write the remainder of what's left over in here, and we're writing in what's left over from each of these terms, and we need to think as we're doing it that if I expanded this out again, I have to get back to the original step. So if I divide this first term, 7a squared b, by 7a squared b, I mean, that's just dividing it by itself. What's left over is going to be 1. Okay. The second term, if I divide it by 7a squared b, well, dividing the 14 by 7 will give me 2, and in fact it's a negative 14 divided by 7, so it's going to be negative 2. Dividing a cubed by a squared, thinking my index laws, something cubed divided by something squared, subtract the powers, it's going to be a. And b divided by b, that's just 1. I don't need a b in here at all. So that's going to be the factored form of this expression. And we can check that we're doing it right. So I'll just put a tick here because that's the correct answer. We can check that we're right if we wanted by doing the expansion again. Okay, 7a squared b times 1 would be 7a squared b. 7a squared b times negative 2a would be negative 14a cubed b. And hey, look, that's what we started with. Okay, so we know that we've done it right.